Welcome to Walkabout the Galaxy, the not no-nonsense astronomy podcast, where the science is universal, the opinions are personal, and the intro is triple negative.
What?
Not no-nonsense.
Ah!
Which
Nice.
is different than nonsense. Which would be, if the double negatives, two negatives cancel.
Yeah.
Uh-huh.
So you would think that just means nonsense.
Yeah.
But it's not nonsense. But it's also not no-nonsense.
Okay.
We are Strange Charm atop the astroquarks, also known as Josh Caldwell, Addie Dove, and Jim Cooney, coming to you from the Walkabout Studios at the University of Central Florida. Be sure to stick around at the end of the episode for when one of us is going to burp really loudly.
Probably Addie.
Our stumpers are sportive.
Okay.
That's like a brand.
Sportive?
Mm-hmm. I already know our sponsor.
No, I don't. No, what is the right adjective? Is sportive?
Sporty.
Sporty? Athletic?
Sporty Spice?
Sporty?
Sporty.
Sportif in
Sportif.
French led me
Just
to
use
sportive.
that. It's not.
Jim, ice fishing on Europa or ballooning on Venus?
So I think you want me to answer ice fishing
I
on
don't.
Europa.
I have no desires pertaining to your answer to this particular question.
Really?
Really?
You should care more about my answer to this question.
Really?
No, you should not. But then I was thinking more about this just now, and I think that I will actually answer ice fishing on Europa, but not for the reason
Predictable.
Now I'm
not for the
disappointed.
reason you might think.
I actually wanted you to give the other answer
Not
now
because
that
it's
you've given
fishing,
that answer.
but because
ice fishing?
Those of you who are familiar with podcasts know that I enjoy fishing. It's a pastime of mine. But because when I'm fishing, one of the primary things I like about it is just like being in nature and being out there and the what you can see.
Right.
But the trouble with the ballooning on Venus, it'd be awesome, but you can't see anything.
Well, it depends what altitude you're at, and I was imagining that you would be at a high altitude
be
where
high-
the temperatures are pleasant.
Right.
Mm-hmm.
Maybe above the clouds. Might be interesting.
Above the clouds? Is that where the
I don't know.
temperature's going to be? I
don't
feel
know.
like if I was ballooning, we'd have to find this out, or we'd have to be.
We need a
Maybe
better
if they're-
cross-sectional picture of what the clouds on Venus
Yeah,
look like.
I feel
for
like
this.
you'd just be in a
You're
dense
just always in
fog,
clouds.
and it'd just look.
Well,
it'd be
yeah,
stupid.
but maybe-
looking.
But it'd be a cool glowy fog, maybe.
A cool glowy fog, but I can get a cool glowy fog anytime. I want
That
the,
might
I want
be
the,
sulfuric acid that's dissolving your balloon.
right.
Maybe there would be some incredible Carl Sagan-esque floating atmospheric creatures that you could see with infrared
Tardigrades.
cameras.
Maybe there's going to be tardigrades.
Floating
Yeah.
in the Venus atmosphere.
Giant Star Trek Discovery-like tardigrades?
No, little ones.
Little tiny
little,
ones?
Little dust grains just floating around.
Maybe.
Okay. Well, I didn't have a preference before
adorable.
you answered, but after you did answer, then all of a sudden I was disappointed. So I
Okay,
guess I did
fair
have
enough.
a preference.
You did care.
To be
I
fair, if
appreciate
you're
that.
ice fishing on Europa,
It's gonna be
you better have
beautiful.
a very good cold suit and a very good radiation suit.
Yes.
On Europa,
Yeah.
you need
It's going to be tough.
a
on
pressure
Europa,
suit.
Yeah.
And a pressure suit.
and a really long fishing line, because how far down do you have to go to get to
Maybe
water?
you're ice fishing. Maybe they've already dug a nice hole.
Yes.
And so you're protected from radiation. It's going to be warmer.
Okay.
Oh, I like it. Now I like it. Yeah.
All
So
right.
you're at the bottom of
You're
a,
at the bottom of a long column.
100-kilometer deep
Yes.
chasm.
But it's been like
But
nicely
then I don't get
decorated.
to see the surroundings like I wanted to see.
That's right.
Oh man, it's a catch-22. It's tough.
You would just be at the bottom of this dark silo that's 60 miles deep.
No, I don't want that. I want a 60-mile long fishing line.
Okay.
That's reasonable.
Addie,
Hi.
flying on Titan or bungee jumping on Mars?
Probably flying on Titan. I
Yeah.
haven't considered bungee jumping on Mars very often. It would
That's weird.
So Mars gravity is my least favorite gravity on parabolic flights.
Oh.
I don't.
Why?
It's just like
It's
iffy
too
in
iffy.
between.
It's too iffy. Make
It's
up
like-
your damn mind, Mars.
It's like you're not quite as heavy, but there's still gravity, and so it's very much like, ugh, what is
Yeah.
this?
But I think part of that,
But if you were just on Mars, it would be different, right?
Yeah.
You wouldn't be in the sort of in between.
it's that going back and forth. If
Yeah.
you got there and got your Mars legs,
yeah. Which would be
and then the
pretty easy to
bungee
get.
jumping, when you're bungee jumping, you'd have this nice fall.
Bungee jumping in general scares me.
Have you ever done
it? No, I've gone skydiving, but
Really?
bungee jumping
You
scares
seem
me.
like unscarable.
It's the snapping part.
That's what I thought.
It's
Yeah.
the snapping part
Yeah, she's
that I
way
don't
bolder
like
than the two of
idea
us,
of.
I
I mean, I
thought.
would probably do it,
Yeah.
but it would worry me. But on Mars, maybe it'd be interesting. I would do rock climbing on Mars.
Okay.
There's some cool vistas you could climb.
Okay. Cool.
And then maybe bungee jump off. I don't know.
Well, today we're wishing a fond farewell to the Spitzer Space Telescope.
Aww.
We'll say a fond hello to a new telescope.
Ooh.
Taking a look at another small planet around a very nearby star.
They're everywhere.
Swirling space-time, and much more. But first, this episode of Walkabout the Galaxy is brought to you by spaghettification.
Yum.
I had that.
If you're thinking about going on a carbohydrate-rich diet, consider spaghettification. Better than any other pasta maker, spaghettification allows you to transform any solid into long, thin strands of spaghetti-like noodleness. Simply bring your raw materials to a black hole, deep inside the event horizon for supermassive black holes, and let the extreme tidal forces stretch and compress all matter into tender tendrils. You won't have long to boil your new spaghettified stuff, let alone eat it as you plunge toward the singularity. Spaghettification may affect the nutritional content of your food. Escape from event horizon not included with spaghettification. Spaghettification! Tastes great, less filling.
Oh.
That's a beer.
Miller Lite.
You got it.
Yeah.
Wow. Pretty good.
Good for me. Jim thought that it was a beer, though. That's pretty
No,
good.
I would have come up with that. Yeah,
Yeah.
That was like a very big thing.
I feel like, yeah.
20 years ago, I feel.
1974 is the date
Wow.
I have for the creation of that particular slogan.
I feel like spaghettification has been very popular. There's all the spiralizing of vegetables, right? Making vegetable noodles has been a
like
big thing.
Making spaghetti from zucchini and stuff
Yeah.
like that.
Were they
Zoodles.
taking their cue from general relativity? And
They definitely are.
black holes?
Yeah.
Awesome.
Right. They're taking their zucchini and
Putting
then
it
like
near a massive-
delicately hanging it near some massive
Gets
thing.
stretched
And
out. You lose the end of it. It just goes away. But you can never get it back. But
space news, there was yet another launch here in Central Florida.
just all the time.
Another Starlink launch.
Yeah.
60 more Starlink satellites. There are 240 in orbit.
I know. It's
At the
crazy how fast they're happening.
I'm seeing more and more consternation on the
Yeah.
on the side of the astronomers.
And other people, too.
Because it sounds like, I don't know, some recent whining, not whining, but because I agree with it, but like
Agitation.
agitation I've heard is just like that SpaceX and is giving, is saying the right things, but then not doing those
Yeah.
things. Like they're saying, oh, we care, we want to make sure that this doesn't harm astronomy, but then just going ahead and launching all these things without actually
Yeah.
Right.
changing
If they
the
continue on the trajectory they're
paths.
on, they'll have more satellites in orbit than the
Than
total
all the
number of all
satellites.
other satellites in orbit in like 3 years or something. Maybe it's longer than that.
I
but
don't think
it's
so.
a very short
No,
amount of time.
it's very
Because
super
there's something
fast.
like, what, 2,000
Right.
in orbit, and they're already at 240.
Right.
So,
Yeah.
it's crazy.
And they're talking about it like many more launches of 60 this
Yeah.
year. So they could be close to 1,000 of these things up there by the end of 2020. So I was mistakenly, in my mind's eye, these satellites were much smaller than they actually are.
They're big.
They are pretty big. 227 kilograms, or about 500 pounds each.
What dimensions? That's easier for me. They're cool the way they deploy, right? They sort of unfold. They're like stacked cards, and then they sort of deploy and unfold from the stack
yeah.
that they're in, and then they deploy their solar panels. So it's like really cool to watch them get deployed until
Yeah.
you think about what's happening.
Yeah. I don't know how big they are, but
Okay. That's a lot, though.
Biggish.
How many?
500 pounds.
That's pretty big.
So that's,
You'd be on
Like
there's like shows on TLC about that. So
what's TLC?
my 500-pound life.
Is that the Learning Channel?
That's what it used to be. I
Okay.
think it's one of those acronyms that
That's
doesn't
just
mean
gone away.
anything anymore.
Okay. They have.
You never watched my 500, or maybe it's 700. It's a
600.
600. My
On the show.
600-pound life is a show
Okay.
on a TV channel.
The Starlink satellites have these ion thrusters. I was thinking about giving you a stumper about ion thrusters or chemical rockets, but I went sportive instead.
Ooh, interesting.
But yeah, they're pretty significant satellites, and they're interesting sort of orbital fact. 24 orbit planes they'll be arranged in, one per hour of longitude around the planet, each with a 53-degree inclination, so that gives you your north-south coverage on the planet, so that
Right.
you've got those things stacked up, and so they're talking 1,000 or 2,000 for their sort of minimal coverage, which means they're looking at 50 to 100 per orbit plane. And the orbit period in low Earth orbit is like an hour and a half or something like that. So anyway,
if we want to observe Polaris, we're fine. Otherwise, we're screwed.
Right,
pretty much.
Well, no, you could observe pretty much anything from the North or South Pole of the Earth.
Right.
I think we're still screwed if we're looking at Polaris from here because they're so low.
Right.
I
Right.
think.
Right.
So anyway, interesting. Nerd news: Picard is streaming, and I don't mean Jean-Luc has to go pee all the time.
There was another launch actually this morning, though.
Although he probably
Electron.
does. Just saying.
He's old.
Just saying. Nothing about Patrick Stewart.
No.
Just Jean-Luc Picard is up there.
Yeah.
But it's the future. People live longer.
So they don't need to pee as much when they get old.
No,
They've taken care of that.
They've
taken care of that whole elderly prostate issue.
Yes.
Okay.
Yes.
So.
But other than SpaceX, Starlink or not Rocket Lab launched their. So this is another much smaller launch company, and they are launching satellites now. They're from New Zealand right now, but there's going to be a U.S. launch site. They're a U.S. company, but they launch in New Zealand.
Okay.
And they launched like a secret NRO satellite today, which
What's
means
NRO?
their National Reconnaissance Office.
Okay.
Ooh.
So it's a secret government satellite.
It's one of those initials that still does stand for something.
It does, yeah. But theirs are also reusable, and they land them. And
oh, really?
But it's a much smaller company. But they're making a pretty big play on the scene.
Wait a minute, they're landing their boosters, the Electron
I think so. Yeah.
Huh. Jim, you've gotten a belated look at the Mandalorian. And
I finally found Baby Yoda. And I complained earlier on the show a few times about Baby Yoda, but damn, is that dude cute.
Right?
Oh, man. Because so he gets introduced in like the first episode or something.
Right.
And then we've only
what hooks
seen
you into the show.
right. I've only seen a few, like 3 episodes, I think, so far.
Talk, Baby Yoda. Talk. That's how the show goes.
Yeah. It's a weird show. It's very slow. It's different than what I
like it.
expected. And I enjoy it as well. But the Baby Yoda is put in danger, not to ruin. I won't say exactly how or what, but he's early on put into dangerous situations, and I got very upset.
Oh.
Very upset. And I'm sure that's what they're going. I mean, like, how dare you put Baby Yoda, who I now love more than my family, in harm's way.
I wish I had been a fly on the wall when that happened to see you get very upset.
I mean, near tears.
Yeah.
Like,
When what happened?
Just Baby Yoda
Baby
being
Yoda,
in danger.
they put him in danger.
Oh, I know.
That's not okay.
That's every
You can't-
episode, Jim.
But no, I'm not.
Just a warning.
I can't watch the rest of this. It's too upsetting. Baby Yoda is too precious.
you're gonna get real mad at
Don't.
Okay.
In addition to Baby Yoda, one of the things I like about the Mandalorian is just the Mandalorian's speech patterns
Yeah.
are very cash. Like he's like, okay, I'll meet you around the corner over there. Well, I got to go pick this thing up, so all right, I'll be there in about an hour.
Yeah.
But he's got the whole Star Wars full armor thing
Yeah.
going on, but he's
Yeah.
not like, I am your father. He's like, could you pick that thing up for me?
Yeah.
So I don't know. I find that sort of charming.
Yeah,
on the Mandalorian.
I like the slow. I mean, we've talked about this before.
Yeah.
I like the slow pace and the just a
Me
show.
too.
That's just a show about people, and I
people
like
in
it.
that universe, right? Yeah. Why does
Yeah.
everything have to be about the damn Skywalkers?
You're gonna be
all
real
the
mad
time?
about Jason Sudeikis, though.
Who?
You won't even know it.
All right.
I
Okay.
didn't know it.
Yeah, he's in. You don't know it's him. He's in a stormtrooper costume.
I did
or
not know
yeah.
Yeah. Well,
I'll tell you after we turn off the.
let's talk about astronomy in a not no nonsense way.
Okay.
Okay. What's first?
Spitzer, R.I.P.
The Spitzer Space Telescope. So,
Moment of silence.
That's enough.
Okay.
This is the lesser known of the space telescopes.
To some
Yes.
people, like
To-
it's
to
lesser known
people
to
who
most
don't-
people.
yeah, if
Yeah.
you asked people to name any telescope, 99.9% of them will say
The Hubble.
Space
HST.
Telescope. And I think that many people are just unaware
raps
that there are
about it.
any other space telescopes out there. There are actually a slew of them, right? Many wavelengths of light you can only see
you
from
used
space.
slew when talking about telescopes.
I
It's
did.
funny.
Ooh, I didn't mean that.
That's for our non-telescope listeners. That's a pun because a slew is the word you used when you say you're turning your telescope.
moving your
You
telescope.
don't turn it; you slew it.
You slew it from one point in the sky to the
I
other.
don't know why. I don't know why that became slewing.
don't
But
know.
also, I now
'Cause it's-
totally want to do a poll to see whether 99.9% would say Hubble Space Telescope or whether 15% say Hubble Space Telescope and 85% say, I don't know any
know.
telescopes.
Yeah.
Okay, that's maybe I meant of the people that could name a telescope.
Yeah.
I'm
yeah.
super curious now.
Yeah.
Anyway,
We'll do a poll.
but probably very few would say the Spitzer Space Telescope.
And part of that is because Hubble does imaging in visible light,
Right.
and also produces these amazing images and things like that. Right? Spitzer is an infrared telescope, and it doesn't produce images in the same way that Hubble does. It's narrow pass bands, so it takes observations at certain wavelengths, and you can like build nice pictures of objects from that. But it's mostly just like you see a spectrum kind of thing.
But even the pictures that you build are just because of the technology of infrared detectors, they're lower resolution, typically lower spatial resolution than
Right.
The pictures that you get in visible and ultraviolet. Mm-hmm. So
And maybe they just didn't have as good a PR campaign. I don't know.
maybe so. In any event, it's being retired. It's still up there.
Yeah.
Hubble is no longer being serviced, but it's still operational, and it will go until it stops being operational, basically. But Spitzer, because it's an infrared telescope, infrared means you're looking at long wavelength light that's emitted by things that are not as hot as like as the sun.
Mm-hmm.
And in order to do that, your detector that's imaging that can't be very warm.
Right.
So
Because it would produce its own infrared light that would screw up your detector.
That produces background noise for
Yeah.
your
Right.
images. And so those infrared telescopes, and James Webb's got this thing, right? That's got the same, has to have a way to keep it cool.
You have to have coolant
And so
or a
right.
cooling mechanism or
So Spitzer had some kind of refrigerator up there with helium, and eventually that stuff evaporates away.
Mm-hmm.
And that's kind of what determined the lifetime of this particular space observatory.
yeah. So it launched in 2003 from Florida, of course.
Yay.
And then in 2009 is when the coolant ran out, basically. And so that was when the primary mission, or they're now calling it the cool mission, ended, and Spitzer's been in its warm mission since then. So like some of the wavelengths they were looking in were still at wavelengths there where you can still use the spacecraft and see things, make
Right.
observations. And I like a lot of the really cool discoveries about Saturn's ring. It discovered the Phoebe ring with Spitzer. So this is a ring that's like
Phoebe ring? All the other rings are named after letters.
I
yeah.
know.
And that's because those are the main rings. So the Phoebe ring is this really giant ring that's much more diffuse, and it's way outside of the main ring system. And
It's so big Cassini couldn't see it because it was basically in it.
yeah.
Yeah. It's a giant ring called the G ring.
There's already a
There's
G
already
ring.
a
There's already a G ring? I didn't
Yes.
even know
Where
that.
is the no? I'm just-
Yeah, the G ring is one of these also nearly invisible sorts of when you look at Saturn through a telescope, you see ABC, and
Right.
maybe F, but probably not F. If you're just looking with your eye through a telescope, you're seeing ABC. All the others are either super narrow and hard to see or super diffuse, and this one is so big, and it's called Phoebe because one of Saturn's moons is called Phoebe.
It's not named after a Friends character.
It should be.
Maybe
Could
it
just
is.
decide it is.
Sure.
And dust knocked off of that moon is what makes that ring, much in the way the E-ring is from the geysers of Enceladus,
Right.
another of Saturn's moons.
But it was named the E-ring before they knew it was from
Just-
Enceladus.
just a
Ooh.
coincidence.
Crazy.
Yeah. And maybe now we would name it the Enceladus ring.
Maybe.
So what are some other cool things that Spitzer has discovered?
So we were looking at one of the sort of compilations. There's lots of good compilations out there of cool discoveries from Spitzer. One of them was that the Spitzer helped find buckyballs in space for the first time. Yeah, so
I love buckyballs.
I know they're so
I love
cool.
buckyballs too. I
The
didn't
spherical,
unaware that they were
well. So these
naturally
are
occurring in space.
these are different than the like the magnet ones. You're maybe
I'm
thinking
talking about
of?
carbon-60.
Yeah,
Yes.
yeah.
Buckminster fullerene.
Yeah. So they found that in some like carbon-rich giant stars that were aging. So
I'll
they
be darned.
detected it in
I
space.
did not know that.
I did not know that. I learned something
Spitzer's
today.
pretty great. And then also, there's been a ton of exoplanet discoveries that have come out of Spitzer. So a
Right.
lot of the WARM mission we've heard about it because we know folks who do exoplanet stuff, but a lot of that has been to discover exoplanets. And they found the TRAPPIST-1 system with Spitzer.
That's one of these that has a whole bunch of planets.
It's got 7 planets that we know of now. And for Spitzer, it's interesting because they can do a little bit of trying to understand. So people use it to just see if there's a planet there, but also maybe what the atmospheres look like because you're looking at specific wavelengths. So you can see maybe if there's an atmosphere of a planet. And Spitzer was supposed to be sort of stop operations in 2018, but they extended it a little bit because James Webb hasn't launched yet.
Sigh.
Right.
James Webb is coming.
Yeah, and of course,
So is Winter.
this is just a small fraction of the stuff that Spitzer did. Anything
Yes.
that gives off infrared light, it has seen. I mean, I think one of the first things it looked at was like very, 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 very old stars or distant stars, that have their light red shifted into the infrared.
Right.
And that's, of course, one of the primary things that James Webb will do, but Spitzer was doing it first.
Yeah, lots of cool astronomy, some interesting planetary science.
Speaking of
Spitzer, was Spitzer one of the great, what are they called? The
Great Observatory?
observatories?
I don't know.
I think so.
But speaking of James Webb, it is not yet launched. It is a great observatory telescope, big NASA project, infrared, and it's going to be not orbiting the Earth, but off one of these
It's in a
Lagrange
J
points.
or an
Sponsor of the
L1.
show.
Thanks, Lagrange.
Yeah.
And and it
L1?
has
L2.
I don't know.
One of those.
And one of the ways, I think L1, but one of the ways it stays cool is it has these big giant radiators.
Yeah.
Tennis court sized radiators to shed heat from the telescope itself. But in any event, while it has not yet launched, they have opened the first solicitation for science proposals to make observations with the James Webb
Again?
Space Telescope. Yes.
Well, it's like
So,
started.
dear listeners, if you want to use the James Webb Space Telescope,
Get your proposals
get your
together
proposal
now.
ready.
Yeah.
And we are hosting a workshop here at the University of Central Florida
Oh, yeah.
on how to put together
Make
those
that
proposals
proposal, Yeah.
All right.
in February of 2020.
It is L2.
Yes.
It's L2?
I know.
Why didn't you say it if you know it?
He went like this.
I did. I put up the piece.
What? This is an audio podcast, Jim.
What? We have very many YouTube followers who would have known.
Yeah.
See your peace sign thrown.
Yeah. Okay.
So,
All right.
so
Speaking of
so-
exoplanets.
So Spitzer is being retired, but we also just started a new. They just started operations on a new solar telescope. That's a ground-based telescope in Hawaii.
Daniel Inouye,
Solar
named after the
Telescope.
former senator from Hawaii.
And it released these amazing videos that just looks like caramel popcorn.
The sun is crazy
The sun is
looking.
super
Stars
cool.
are stars
Just
are
makes me
in
hungry.
principle simple, but in the details are super complicated and pretty
yeah.
fascinating to look at.
Yeah, you look at the sun, you're like, it's a yellowy
Yellow
disk.
spot.
But then you zoom in, that's
Yeah.
freaking crazy.
Yeah. So the picture, which we'll post from this telescope, shows things that we've seen before, but in the higher resolution than we've ever had before, of these sort of convection cells on
Yeah.
what we call the surface of the sun,
The
which
photosphere.
which sort of is like it's sort of like the cloud tops of the sun in some sense.
Mm-hmm.
It's not solid or anything like that. It's just below that you can't see where you're going, and above that the light goes.
Yeah.
And it's got this crazy caramel popcorn popping
Yeah.
convection thingy
Just like
going.
or boiling caramel or something. Yeah.
Yeah.
It's definitely because they're convection cells, so they look like what happens when you have a thick substance that's boiling. So you get these little pockets that
Yeah.
are like the size of Texas.
If you could color them,
Yeah.
magically
well, you can
somehow.
if you make caramel.
Oh. Well, the only thing I've ever boiled is water.
Oh, well, I've made caramel, and,
And
it looks
like
very
that.
similar.
Yeah.
Hence why you
Sometimes
said
bubblier,
that.
but yeah.
Okay.
Yeah.
Because it gets dark on the surroundings.
You just get convection blobs. Sometimes you get a lot of foam. Anyway, this is not a cooking podcast, but it looks very similar
be.
to boiling a thick viscous substance. Yes.
Okay.
It's cool.
All right. Fun.
Yeah.
Speaking of exoplanets, which, as you said, many of Spitzer's discoveries were about, there's a new planet candidate around Proxima Centauri.
Ooh,
Proxima Centauri.
Let's go.
That's the closest star.
Yeah, besides Sun, remind us about Proxima and Alpha. When I was a kid, it was always Alpha Centauri. Then I was just like, it's Proxima Centauri.
Yeah. So Alpha Centauri is a multiple star system. And there's Alpha Centauri. I think there's Alpha Centauri A and Alpha Centauri B.
Yep.
And then there's Proxima Centauri, which is probably gravitationally bound to Alpha Centauri A and B. And so
But
it's
it's
like a
super
triple
far
star
away,
system,
though.
but it's much farther. Alpha Centauri A and B are really close to each other. Proxima Centauri is further away, and it's actually the star that's closer currently to the sun.
Oh, yeah, but if they're orbiting, will it be?
They're orbiting, so it's not. I mean, it won't always be.
So if it's on some big distant orbit around the Alpha Centauri stars, in some number of years, it'll be further away.
Yeah, but it is.
And they're all basically about 4 light years away. Is that right?
Right.
By the time we can get to it, it won't be Proxima Centauri anymore.
Well, we've decided to
we'll
name
have
it
to
that,
see-
so it's
we'll
always
have to
going
see
to be
when
there.
we get there. Yeah.
But yeah, it's got planets, eh?
It does. So it's an M5 star, so somewhat cooler, significantly cooler. Why are you giving me that look?
I was just laughing because M9.
M5.
Yeah.
M5 is a Star Trek reference.
Oh, and we have a joke about M9 in our lab. So
M9?
Yeah.
Not M5?
no, it's M9.
It's M5.
In the lab, it's a joke because it's M9.
Irrelevant.
Anyway, we're gonna cut
Arg.
this part.
M5 is the ultimate computer in Star Trek Original Series
Yes.
episode The Ultimate Computer, and it's a spectral type of a star that is cooler than the sun, and it seems to have a planet that is probably significantly more massive than the Earth, but not probably not a giant planet. So we're talking about 6 times the mass of the Earth.
Is that a super Earth?
I think
I
it's
wanna
a
say that's a-
Neptune.
I can't remember. They have these funny categories. There's super Earth, and then there's something that's sub Neptune. It's
Yeah.
I keep losing track because all the planets that we see around other stars are not like ours.
Right.
So we have our nice categories here in this solar system, and all the categories in all the other solar systems are different. But about 6 times more massive than the Earth, whereas Jupiter is 300 times more massive than the Earth. Uranus and Neptune are like 25 times more massive. So it's somewhere in between Earth and Uranus in mass. 5-year orbital period, but nearby.
So
Yeah.
close.
Like 4 light years. That's super nearby.
That is
It's really
as
close.
stars go.
As other planets and other stars go.
Unfortunately, even if we were going something like 50,000 miles an hour, it'd still take a few 100,000 years to get there.
'Cause you gotta speed up and then you gotta slow down.
It's just a whole thing. Getting there is just a whole thing.
Yeah,
I mean-
if you decide you don't want to slow down
That's
and you
true.
just want to send a CubeSat with that giant laser pulse that that
Oh,
one
yeah.
initiative wanted to do.
Yeah,
you
yeah,
get
I know.
there in
I
maybe
I wonder what
100
progress
years.
they've made. I haven't heard anything about that in a while.
I don't know.
Hmm.
I don't
So
know.
there have
wondering.
been other planets discovered around Proxima Centauri previously. So this is just the newest one, I think.
A new low mass planet at
Yeah.
a distance of 1.5 AU from the star, which is about the same distance that Mars is from our sun.
So does that put it in the habitable zone?
The Hubble?
Yeah, something like that.
No, because it's a cooler star.
Right. So,
So-
habitable zone is closer.
Temperature-wise, I think our sun is pretty cool.
But it is a potential target for actual direct imaging of a planet. It's
Ooh.
not super, super close. It's not a super bright, it's not super close to the star. It's super close to us as these things go.
Right.
It's not super close to the star. It's a good enough sized planet. We might be able to characterize an exoplanet with direct imaging more easily with this one. Well, speaking about planets, we'll use that to our
very
trivia
smooth transition.
to segue. Our trivia is planetary,
No way.
transitioning to astrophysical.
Great.
After the trivia, so let me drop it.
Jim's like, finally, I'm interested.
Let me drop some trivia on it.
planets.
Uncharacteristically, I have an incredibly simple trivia question for you.
Oh,
Whoa.
that is uncharacteristic.
Uncharacteristic. It does not really involve multiple parts or long, complicated introductions.
But you
Okay.
still
To
made a
my
very long
chagrin.
introduction
I'm
based on
doing my
that.
best.
Okay.
Where is the tallest cliff in the solar system, and how tall is it? I'm giving you a multiple choice
Okay.
on the location, not on the height. 6 choices: Venus, a planet; Mars, another planet; Enceladus, the moon of Saturn; Vesta, an asteroid; Miranda, a moon of Uranus; Charon, excuse me,
You okay over there?
a moon of Pluto. Those are your choices.
That is fascinating. The one I was going to choose, if I didn't have multiple choices, was not on that list.
What was it?
What
Mercury.
Oh.
I was thinking of the what are they, scarps or something like that on Mercury that are
there's
these.
definitely scarpy stuff. I should have put Mercury on.
You would have got me.
You would have gotten him.
As a distraction.
But clearly, I mean, it makes sense to me that that's not the answer, but I'll say why later.
Okay.
Right. Well, that's going to be part of the fun when we get to the answer. Is
How tall?
Well, also how tall, but also why
Yeah.
the right answer is the right answer.
Right.
Okay.
So
'Kay.
we'll come back to that. But now let's journey out into the realm of Jim.
Don't get me wrong. I love things on small scales too.
You love the realm of Josh and Addie?
The realm of, yeah. And actually, this thing we're talking about is on small scales. We're talking once again about the warping of space and time.
I do that.
Warp space and time. You do
Sometimes.
warp space and time. That's how GR works.
G equals 8 pi RT.
There you go. So this is one of the neat predictions of the theory of general relativity is that spinning objects will warp space, and we've mentioned this a few times on the program before.
I never understood.
Right.
So
Really?
Really?
You're an idiot.
No, it's not how I meant it.
Confessing right here, I don't understand frame dragging. Like, and that implies that I do understand general relativity at some level, which beyond the G equals 8 pi RT level, I don't really even understand that. But at least the bowling ball in the giant sheet of rubber illustration of general relativity, I do understand.
But like, what if you put the bowling ball and it's got a little friction? So as you start to turn it, it pulls the cloth with it.
Because of that word friction, that's the part that's got me.
Why?
Well, I don't understand how there can be friction with space.
Because everything's connected.
Right. The idea here is I mean, we're not going to, the visual here is we'll once again go back to our molasses, and if you had, if you had
It's caramel.
a tennis ball.
was
We were
caramel.
talking about
Is that the
caramel.
same
Oh,
thing?
okay. Well, we'll do that. We'll put it in some caramel. You buy a tennis ball and caramel, and you spin the tennis ball. It takes the caramel and drags some with it, and here the caramel is space or space-time, and the tennis ball is some kind of planet or star or something like that. So anything that spins in space carries space with it as it spins around a little bit.
Doesn't everything in space spin?
Well, not everything,
much.
but pretty much.
Mostly.
But again, this effect is a tiny effect for something like the Earth. The Earth is of course spinning, but it's not only is the Earth's mass fairly small as far as astrophysical things go, but also it's not spinning all that fast.
Yeah.
Even so, it should be dragging space with it just a hair, just a little bit.
Did you explain
I didn't.
how that
Not yet.
happens and I missed it? Okay, good.
No.
All right, good.
Well,
Hang on.
Just checking.
Hang in there.
I'm hanging in.
No, I'm not really going to explain it in any greater detail than that. It just does.
Oh, it just does?
It's
Well,
look,
yeah. That's not an explanation. You can't say I'm not going to explain it
Well,
any more than just saying it happens.
in a sense, it's not. It's saying it does. So you love the bowling ball on a sheet of rubber kind of analogy for
I
how.
Boy, does he.
love
He
a
loves that. He
bowling
loves
ball on a sheet of
On a
rubber.
sheet of rubber. I mean, there's no more fun than that. But that's actually a crappy analogy as well, because the only reason the bowling ball causes a change in the shape of the rubber is because of the existence of gravity. But this is supposed to be I mean, the whole thing is a crappy analogy to begin with.
I mean, it's a fine analogy.
Let me have my bowling ball and sheet of
And
rubber.
don't get me wrong, when I say crappy analogy, I mean it's a great analogy, but so is this thing. This is why Addie didn't have a problem with it. But is that same sheet of rubber? I mean, if you can bend it using gravity, you can also.
Well, this thing has a name. This
Frame dragging.
Yeah, it's called frame dragging or the lens thirring effect.
Right. So those two people wrote a paper, and they didn't just say it's like if you put a tennis ball in Addie's boiling pot of caramel.
No, what they did was they worked out
and spin
they
it.
took the equations
Next
of
paper
general
title.
relativity.
A bowling ball in Addie's pot of caramel.
No,
That
they.
could be the
Is it
episode title.
caramel or caramel, by
Caramel.
the way? Caramel.
I'm from the Midwest. It's
It's
caramel.
caramel.
You say caramel? I don't even know what to say. It's like
delicious, though.
It's like the Hadron.
You know
Hadron
what?
thing.
You know what? If you have some in your mouth, it's hard to say anything.
That's true.
All right.
Anyway,
All
frame
right.
dragging.
Frame dragging.
In caramel.
So
So-
masses twist space when they
Matches
rotate.
Right. We sometimes call this gravitometric stuff. So that is, it's in analogy to like if you have a spinning charged particle, then you have magnetism.
Yes.
Right? And this is the gravitational analogy to that. You take I mean, if you just have a charged particle sitting there, you have electric fields, and you spin it, and now you have magnetic fields, and it's a similar thing for gravity. You warp space and time by just putting a massive object there. If you spin it, you have these additional effects on space and time. And
because of magnetic fields and electric fields.
Not because it has nothing to actually do with magnetism or electricism.
Or bowling balls and sheets of rubber.
Right. But nonetheless, it happens.
Anything.
And we've tried to measure this effect before using Earth, right? I mean, this is obviously where we are.
And we have measured it before.
Ish.
I thought it worked.
It kind of did. We claim it works, but
Gravity
it kind of didn't.
Probe B, correct?
Right. So there were actually two missions that we sent out there. One was called Grace, and one was called Gravity Probe B.
What happened to Gravity Probe A?
That was a successful mission as well, but measuring something different.
Oh, okay.
So these were designed to measure this frame dragging effect, and both missions have claimed to have seen it, but it's at a very low level of
1 plus or minus 1.
Yeah, that kind of thing, right? So the uncertainty in the measurement is very high, and so.
But not surprising because, as you said, the Earth is
so hard to measure. This frame dragging is such a tiny effect compared to all the other. The trouble is, there's all kinds of things that affect that gravitation. Like you have a mountain on Earth, and that makes the gravity different above where you are. And I mean, like all of these things, frame dragging is such a tiny thing that it's really hard to measure. So we probably measured it with Gravity Probe B, but not absolutely certainly.
Okay.
But so what we need something that's way more massive and spinning a lot faster, and that will cause the frame dragging to be
Neutron Star.
Yeah.
Ooh, Neutron Star. So what we have is a system with a neutron star and a white dwarf.
Ooh.
Two of the cool stellar remnants orbiting each other. And the
spicy.
It is spicy. The neutron star is a pulsar, which is has the very sexy name PSR. J1141-6545.
Stop.
That's going to be the name of my firstborn daughter.
Ooh, interesting.
Yeah. That's going to be awesome.
Yeah.
And so in this system,
Spitzer for short.
Spitzer, sure. Okay. In this system, the white dwarf is actually spinning much more quickly than a typical white dwarf spins.
Okay.
And what we can do is look at that orbit of those two things around each other. And what we notice is that there's an anomalous procession to the orbit. So that is the orientation of the orbit.
We have to define procession.
Well, it's just like if you take a top and spin it, it's spinning, but it also wobbles.
Like a weeble.
Yeah. And that wobbling is, the fancy physics word for that is precession. Right. And so
planets do this.
Slew your telescope over to see the
So anyway, it's just like this gentle change, subtle change in the look of this orbit of the pulsar and white dwarf. And we've realized it's because of frame dragging. So
fun fact on precession.
Yeah.
So if another way to look at it is orbits are not circular generally.
Right.
Is this a spin precession? So that's the top analogy.
Right.
Orbits also precess.
Right, and that's what I'm talking about here.
You're talking about orbital precession.
Yep.
And it was the precession of Mercury's orbit that was disagreed with Newton's theory of gravity that Einstein's theory of general relativity famously resolved.
It all comes around. Einstein wins every damn time.
Yeah, I would never play that guy in poker.
No.
But Stephen Hawking did in Star Trek The Next Generation.
It's true.
I have to go back and watch those episodes to figure out who won. I don't remember. I wouldn't be figuring.
Yeah.
It would just either be there or not.
So the kind of end result of this is yet another win for Einstein, right? So another of the predictions of general relativity that has been borne out, this frame dragging effect, very hard to measure around Earth, but more easily measured in this pulsar white dwarf system.
Cool.
And the precession of the orbits of these things precisely match with much less uncertainty, precisely match the predictions of general relativity.
I'm super disappointed that you did not explain to me how it is that something spinning does this lens theory frame dragging thing, but whatever.
Because in your head,
it's okay. In my head,
it's not okay to use
space is not a thing. It's just like the setting in which things act. But that's not the case in general relativity. It is a player and not just
A plier?
A player.
A player.
Oh, I
It's
thought you
playing the
said a
game.
plier.
It's playing the game.
Playa.
It's a sportive thing.
It's a sportive thing.
It's a sportive thing. All right, cool.
I have to say there was this one phrase in the article that we just discussed, and it was that it's a post-Keplerian parameters.
Oh.
Post-Keplerian just sounds very like some sort of age to me.
Yeah. Right.
Post-Keplerian
it's like postmodernism.
age. Yes.
Post-Keplerian, referring to Kepler. All right, let's go back to our trivia.
Oh, right.
Yes. Where is the tallest cliff in the solar system?
Is it causing frame dragging?
At some tiny, tiny level, yes. Some tiny.
Fair.
Venus, Mars, Enceladus, Vesta, Miranda, or Charon? 2 planets.
All right.
3 moons or an asteroid.
They're all planetary
I
bodies.
have
All worlds
my
worthy of our admiration and interest.
Interest. What's your guess?
Vesta.
Oh, I was maybe I'm gonna go with Mars.
I got you both.
Darn it.
I got you both.
Is it one of the other ones?
Yes.
Okay. All right.
It is Miranda.
Miranda.
I wondered if
Most likely. Because we don't have
Oh.
the greatest observation, but the second runner-up, if it isn't Miranda, might be Charon, in fact.
really
Charon, we
these
have
icy moons.
these icy moons. So, yeah. So one reason Miranda's this tiny moon of Uranus, and we've only seen it in detail from the Voyager 2 flyby in January of 1986. And we just saw one side of it, and it really looks absurd. Right? It looks ridiculous. It looks like some, kid's random drawing of something. It doesn't make
That's awesome.
any sense physically. It has these giant oval, like racetrack features on it. Just looks like something that was blobbed together out of Play-Doh. But on there is something, the moons of Uranus, there's a Shakespearean theme, and the features on Miranda are named after locations in Shakespearean plays.
Oh.
This is called Verona Rupes. I'm probably not pronouncing
The cliff is
second
called
word.
Verona Rupes?
Yeah.
Okay.
Oh,
Verona.
Fair Verona.
At least, yes. And is maybe 20 kilometers high. Probably
I thought we were
at
supposed
least,
to guess.
You were supposed to guess.
It's okay. It's been a long week.
Is probably at least 10 kilometers high. Interestingly, so why such a tiny little moon, just a couple hundred kilometers across?
Yeah.
Why does that make sense?
That makes sense.
Right?
Because gravity.
Because gravity, if you got a giant gravity, it's really hard for such a giant feature to stay
To
instead of
exist.
slump down
Yeah.
and round out. On Charon, there's something that may be about 9 kilometers high, but the resolution and the lighting and everything makes it hard to really determine. Fun fact, if you're going bungee jumping off
Yes.
Verona Rupes on Miranda,
Sounds.
it would be a really long fall,
Yeah.
minutes, because the gravity is so weak.
And then you'd bounce up and you'd go really high.
You
Because
would.
gravity's so weak.
That's right.
Oh,
Yeah.
That would be a fun.
It'd be pretty cool.
I'd be much less scared. Also,
You
because
definitely-
reach-
You would
Yeah.
you would reach a pretty good speed if you went all the way to the bottom. That'd be a really long bungee cord.
I mean,
though, by
not
the way.
quite all the way to the bottom.
A 10-mile long bungee cord. You definitely would want to make a better height measurement
thank you.
than we currly have before you did that jump.
Maybe just make your bungee like 5 kilometers just in case.
I'd go like a couple hundred feet.
I mean, any of these are very, very long bungee cords.
But since there's no atmosphere there, you wouldn't reach terminal velocity, so you keep accelerating all the way down. Because it is so high, you would be going at a pretty good clip by the time you reach the
Snap.
bottom. So you do need to have a bungee cord or something like that to protect yourself. Anyway, Mercury is a good, but I'm pleased that what did you guess? Vesta?
I guess that's
Because it was
I think I
small?
just glossed over Miranda. I think Miranda's got to be smaller than
It's
Vesta.
tiny.
Oh, yeah.
It is
Yeah,
smaller.
yeah. And I for
You
some
thought-
reason when you were reading those, I was looking for the smallest one, and I just didn't hear Miranda properly or something like that.
Yeah. All right.
And because Vesta is smaller than the other
Objects.
So small. I want to say, is that true? I don't know.
I'm not sure how it
small.
compares to Charon.
It's got to be similar to Charon, right? I mean, both of those are
Right.
like borderline in equilibrium, borderline
Right.
spherical,
Yeah.
They're spherical. Yes.
but only barely.
Well, it may have felt like the time to fall from Verona Rupes. It was just another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, write us a review using cooked spaghetti and post it as a new recipe on Pinterest.
Have you just learned about Pinterest?
Kind of.
Okay. Pinterest.
That look was because I wasn't sure if that's how to pronounce it. That's very Pinteresting. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see our unfiltered looks of surprise and astonishment. Catch up on old episodes wherever you get your podcasts. Check out our website for our cool Walkabout t-shirts.
Yes, get a t-shirt.
Thanks to our listeners in North Carolina and the USA and around the world. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Frame dragging.